Hi there, we're working on 2.6 and problem number 4. This one has to deal with an angle measure and a plane flying overhead. So a plane with an altitude of 4,000 feet is flying west at 700 feet per second. A searchlight underneath its path tracks it. How fast is the light pivoting when the plane is 1,000 feet east? Let me take you over to a file here. And this one is a nice demonstration of, I'm going to hide that, but let's just watch the plane fly. So down below is this searchlight and it's tracking the plane. And here it comes, it's going from east over to west. And we want to know when is 1,000 feet east of the searchlight, what is d theta dt. So what we're going to try and find is the rate of change of theta. So that's going to be a d theta dt that we're interested in on our problem. So if I hit 1,000 and let's show d theta dt, that is the answer that we're going to try and match up to. So we'll see if we can make that happen. Let's start out by doing the triangle, just like we had done there or saw on that page. So we've got a right triangle, and we know that the plane is 4,000 feet altitude. So it's staying steady. That we can lock in because that will never change. We know our searchlight is down here. There's theta and it's pivoting as it's following the plane. The plane is going at a certain rate of speed, and the distance it is away from theta, the searchlight, would be x. Let's let that be x. Now, up here, we got the 4,000 taken care of in our picture. It's flying west at a rate of 700 feet per second. That would be dx dt then, reading on that feet per second. Since it's in a westerly motion, I'm going to put negative because it's closing, it's coming in, it's closing the gap, so it's getting smaller and smaller. I'm going to say then that that is a negative movement. And a searchlight under its path tracks it. How fast is the light pivoting? What we want to find is d theta dt. That is what we are seeking. And this is what we know up here. At or when the plane is 1,000 feet east. So when x is 1,000. If I put the 1,000 in right now, I could have a steady, static triangle, but what we want is the variables to come into place. So when I write my main equation, I still need x to be part of my variable and theta to be my variable, because those are the two variables that are constantly changing as this plane flies. How do I relate x and theta? How would you do that? Well, since it's a right triangle, let's use trigonometry. We could say then the tangent of theta is equal to opposite over adjacent. And that's how I get my main equation built. And then we could do the derivative, and we'd have secant squared. So I'm going to write over here that I'm doing the derivative. That will get us our rates, right? Secant squared theta, d theta dt. The derivative of theta itself, like chain rule, will be d theta dt, equals 1 over 4,000, just a nice multiplier. The derivative of x will be dx dt. So I've got two things multiplying there. Well, one is a coefficient. Okay, this looks really good. What we want to do is fill in information. And I wish I knew what secant squared theta was, because then I'd basically be done. I need to get just d theta dt by itself on this left side, don't I? Now, go to the triangle and let's calculate out this side at the precise moment when x is 1,000 and we're at a height of 4,000. That's going to be a Pythagorean theorem problem there. The Pythagorean theorem will get us that information. Leg squared plus leg squared will equal, should we call it c, will equal this c squared. And if you do the work on that, you are going to find out that this is the square root of like 170 million, I believe. Okay, I took a moment here and I calculated it out, and I was off by 1 0. How about 17 million is our value there? Take the square root, and you're looking at 4,123.1056. Okay, and that is the value of C. Now, what do we do with that? Well, secant is defined as, secant is 1 over, okay, what is secant? Secant is 1 over cosine theta. And that means then that secant theta is equivalent to hypotenuse divided by adjacent. Hypotenuse divided by adjacent. Well, my hypotenuse was the square root of 17 million. I want to keep my accuracy. So I'm going to have the square root of 17 million over hypotenuse adjacent. Here's my theta, so this would be my adjacent side, correct? That would be 4,000 there. I've got to square that value, and then that would be times d theta dt is equal to 1 over 4,000 dx dt at this moment, well, it stays steady, is negative 700 feet per second. So now it's just really throwing it through the calculator to get our answer. Okay, pause for a moment. I put in my calculations here, and we did get the correct answer. So what I did is I multiplied by the reciprocal of this square root 17 million divided by 4,000, and that's what you're seeing right here. So I've got squared on each, and I put all this into the calculator, as you can see right up here, and then the answer came out to be this. So d theta dt is rotating at a rate of negative 1.647. And that would be radians per second for a label. Very good. I'm going to record the next one on a separate video.